All right, so I want to apply the chain rule to a general situation and come up with what's called the generalized power rule. And it's worth memorizing and using as a standalone formula, but you need to realize it's just the chain rule. If you forget this, just use the chain rule. So here we go. So the situation is this. You want to take the derivative of some function, say g of x, that's being raised to a power. Does that make sense? You have a function, you're raising it to a power, and you want to compute the derivative of the whole thing. So let's think about it together. The outside function is x to the n. The inside function is g of x. And so you take the derivative of the outside, which is nx to the n minus 1. You plug in the inside, which is g of x. And so you end up with n times g of x raised to the n minus 1 times g prime of x. And that's it. So I just did the chain rule. That's all this is. It's just a chain rule. But it's worth noting this particular example of the chain rule because it's so common. So I thought we'd do maybe one or two examples right away and see how this works. So this is example number, let's see, number 3. So here we go. So I want to consider the function g of x equals the square root of x squared plus 5. So I'm going to view this as x squared plus 5 all to the 1/2. And now I'm going to realize, oh, I can use the power rule on this. And I'm just going to do the generalized power rule. G prime is going to be pull the 1/2 down. So you get 1/2 x squared plus 5 to the minus 1/2 times the derivative of the inside, which is 2x. And so this becomes 2x over 2 square root of x squared plus 5. This 2 is the same thing as this 2. This 2x is just staying upstairs. The minus flips me downstairs, and of course the half makes me a radical. So I'll cancel the 2's, and I'm going to write this as x over the square root of x squared plus 5. That's the derivative of g. That's your g prime. Let's do another example. So this will be example number 4. Let's look at y equals 1 over x squared plus x plus 1. And again, I want to show you two different ways you can work this out. So option A is we're going to use the chain rule, which is really, in this case, going to be the generalized power rule. It's the same thing. And then option B, let's use the quotient rule, and you can decide which one you think is easier. So to use the chain rule here, I'm going to realize that I can write y itself as x squared plus x plus 1 all to the minus 1. And that means that y prime is going to be minus 1 x squared plus x plus 1 all to the minus 2. That's just the generalized power rule on this thing. And then you're going to multiply by the derivative of the inside, which is 2x plus 1. We want to clean our answer up a little bit, so we're going to leave this as, well, first off, the negative we'll just put upstairs. So it's going to be negative 2x plus 1 upstairs, and then x squared plus x plus 1 all squared downstairs. So that's y prime. Now let's work it out as a quotient. So if I want, I can just use the quotient rule directly. And so when I do that, I get y prime is the derivative of the top, which is 0, times the bottom. So 0 minus the top times the derivative of the bottom, which is 2x plus 1, all over the bottom squared. And so pretty rapidly I get that y prime is negative 2x plus 1 over x squared plus x plus 1 all squared. And so these are exactly the same thing. So it all depends on how you think about it. I would say one really isn't that harder than the other. Perhaps the quotient rule is a bit easier in this particular problem, but we'll need to be able to go back and forth and do both. Let's do one more example. I'm not sure how many, I promise, but I'm just going to keep saying one more. So example number 5, let's look at the function f of x equals, let's just do x to the 5th minus 2, let's do plus 2x plus 1 all to the 2020. And so again, you can recognize this as a generalized power rule. So f prime is just going to be, f prime is going to be 2020 times the same inside, x squared plus x to the fifth plus 2x plus 1 to the 2019 times the derivative of the inside, which is 5x to the fourth plus 2. And that's really about all you can do with this problem. I guess you could move this factor out front if you wanted to, but I mean, it's fine. So let's stop this video here, and then we'll do more examples in the next one.